Okay, so division of complex numbers is, like I said, it's more like rationalization of the complex number. Because once you get to a point where you just have two complex numbers, there's nothing that you can do in terms of trying to find another number. So the only thing that you do is you just rationalize. So for example, if I had a plus, in fact, let me give actual numbers. So if I had 4 plus 5i over 6 plus 2i, this is what they call division of complex numbers. There's nothing that I can do with these numbers to get another complex number. For example, I can't get, let's say, something like 2 plus 3i, just like that. I can't get this. So what mathematics, what you do is you try to rationalize this part. Rationalizing meaning that we are trying to create a real number from the divisor, so that this could probably now become, let's say, 2 plus 3i. I'm not saying this is what you get after you rationalize. I'm just giving an example. Then you have a real number there. Okay. So it's not essentially dividing, I would say, but it's just to create a rational number down here, a real number down there. That is what they call division of real numbers, of complex numbers. Now, the concept is based on creating conjugates. Okay. So now these conjugates, what are they? A conjugate will be, let me just show by example. So if I've got a plus bi like this, the conjugate of this number will have the same real part, the same imaginary part, but then they'll just have a different sign here. So the conjugate of this one will be a minus bi. So if I multiplied these two, I'll get a real number. Okay, so if I had, let's say, 2 plus 3i, right? The conjugate of that number would be 2 minus 3i. So notice the difference is the sign in front of the imaginary portion of the complex number. So if I multiply those two, I get a rational, or I get a real number. Okay, so let me show an example. Okay, so this is the format of that of the complex numbers we've been talking about. So if we're looking for the conjugate of that one, it would be a plus bi. If we're looking for a conjugate of this one, it would be 5 minus 2i. Remember we said that this is the sign that we changed to create another conjugate. So if I am getting z times its conjugate, then I'm going to have 5 plus 2i, and then I multiply by, like that. And then we say that if we have x minus y times x plus y, we say that our solution here is going to be like that. Okay. So which is going to be the same here. We square 5 square minus in between, and then we have 2i squared. So therefore this one will give us 25 minus this one here will give us now 4i squared. Now remember we said that I squared is minus, so we're going to say minus, and then inside here -1 times 4 will have -4, meaning that these two are going to add. Then we have 25 plus 4, and so our number is going to be 29. So what does it mean? It means that we multiplied this number, the complex number, by its conjugate, and then it gave us what? It gave us a real number. So this is the basis that we use to rationalize the complex number. So now let's do 2 examples of rationalization. Given a complex number, like this, and they say that you need to rationalize it, meaning that you're supposed to remove the I from the denominator here. What do you do? So the first thing is to check that your number is actually in the correct format. So here we know that this is not, because we said the complex number is always supposed to be in that format. Now you can see the I is here. So we need to change this. We will say that it's going to be like that, then plus I. That's our correct format. Now we know that for us to rationalize, we need to find the conjugate first. So the conjugate of this one will be what? The conjugate of minus 4 plus I is actually, now we just change this sign. Don't mess around with this one. So that one remains, but this one now changes to negative. That's the conjugate. Now on rationalization, what we do is that we get this same conjugate and multiply it to, so we multiply it on top here, okay, and make sure it's the conjugate. So I put it here, and then again I multiply it here, okay, like that. So the whole theory here is that you're multiplying by 1 because this is the same number dividing by itself. So that's going to be that. So now I simplify this. I can put a 3 here, and then I multiply like that, retaining my contents there. And then here I can now expand this. Remember, we go back to our same concept. If I expand this, I need to get x squared minus y squared. So here I'll get minus 4, meaning that I'll square the first term, which is this one here. And then I'll square the second term, which is minus I. But then I need to remember that there needs to be a negative in between here. So I'll do I'll do I squared here. Okay, so that is my concept here. And then what do I do here? I just simply expand. So that'll be minus 12. Then again, negative here, 3i. Okay. Then I divide with, this one gives me a 12, a 16, positive 16. And this is a negative 1 times negative, so that's plus 1. So my complex number is minus 12 minus 3i over 17. Okay. And we say that this is okay like this. You can leave it like this, or because these signs are both in front of these singular numbers, you can actually negate the whole thing. You can say 12 plus 3i over 17, because this negative now is in front of the whole complex number. So this would be this same number, but now in rational format, where you have a real number they're dividing. Okay, they're asking us to rationalize this one. Okay, so how do we rationalize this one? So we need to be very careful here. So we're going to make sure that we find the conjugate first. The conjugate here is 1 minus 2i, because we check the format is, yes, it's in this format, right? So we can just simply proceed. Okay, so now we can simply proceed. Now we are going to put 3 plus I, okay, over 1 plus 2I times, we're going to multiply with the conjugate of this one. The conjugate is going to be 1 minus 2I. And then here, we're going to have the conjugate as well, 1 minus 2I, like that. Okay, so I'm going to do expansion of both. This one, the expansion is going to be the normal expansion. And then we have this one here. Like that. Okay, so I'm going to expand this. I'll say 3, 1 minus 2I, then plus I, we're going to have 1 minus 2I, and then at the bottom here, we're going to say 1 squared minus 2I squared, like that. So let's continue from the top here. We're going to have 3 minus 6I. I'm continuing here, plus that one will give us I, and then this one will give us minus 2I squared. Then we divide. Here is going to be 1 minus, here it's 4I squared, 4I squared. Okay, so we continue, right? So now here we can repeat this one. Those two can add. We get minus 5I. Then this one we continue. Remember, here is 2I squared. And then I, we said is negative 1. So this becomes plus 2. Then we continue with our division here. This is 1. And then this is minus 1 times minus. So we're going to get 4 here. Okay. So now here we get 3 plus 2 minus 5I, then over 5. So this one gives us 5 minus 5I over 5. I can factorize 5 to give me 1 minus I divided by 5, which now gives me, these can take care of each other. Then we have 1 minus I, like that. So this is the rational form of this one here.